Alright, so welcome back to the video. So in today's video we're going to be talking about friction and inclined planes. So starting with friction, what is friction? Friction is a force that opposes the relative motion of two bodies in contact. So when two bodies are in contact, friction actually prevents them. It is a force that wants to prevent them from sliding over each other. Now, for example, look at this random individual dragging this particular box. So because of friction, this box will not want to move. Why? Friction is going to act to prevent the motion, because this body now is in contact with the ground. So we have two bodies in contact with each other. So friction is going to actually prevent this body, from sliding on the ground. So it's a force that acts between two, that prevents the motion between two bodies. So that's what friction is all about. And friction can actually occur in solid, in liquid, and in gases. So in gas we refer to friction as air resistance. In liquid we refer to friction as viscosity, and in solid we have like varieties of friction. We have various types of friction. We have static friction, we have dynamic friction, we have rolling friction. But in liquid we only have one, which is viscosity. In gas we refer to friction as air resistance. So friction is just a force that is preventing motion, between two surfaces in contact. Okay, so now talking about friction and Newton's first law. What is the relationship between friction and Newton's first law? So Newton's first law says that a body at rest stays at rest, while a body in motion continues in motion unless acted upon by a net force. So if you look at it, when you kick a ball, the ball will move for a while and stop. But according to Newton's first law, it's supposed to continue to be in motion. But Newton's first law actually says unless acted upon by a net force. So that net force is what we call friction. Friction will tend to slow the body down because it does not want the body to move. It does not want the body to have motion. So it will definitely slow it down as the ball keeps moving. So that's why when you kick a ball, the ball over time will come to rest. So it's coming to rest because of friction. So that's the relationship between friction and Newton's first law. Alright, now we have a box on an horizontal surface. So according to Newton's third law, which says for every action there is an equal and opposite reaction, we can now find the relationship between normal reaction and the weight. So now this is a box. The box has a weight which acts downwards. So it has a weight, and we know weight always acts downwards. So because of Newton's third law, this weight is the action. There will be a reaction which is directly opposite to it. So that action is what we call normal reaction, and it's represented by R. Normal reaction. So these two act opposite to each other. So once your weight is acting downwards, your normal reaction is acting upwards. So after noting this down, that this is the action, this is the reaction, we also have two action and reaction forces acting again. So now let's say you try to push this box. So you apply a force. Let's call this F. Now what is going to react against this? This is the action force. So what we want to prevent this box from moving, that's what's frictional force. So in this case, frictional force is the reaction force. So frictional force acts to prevent the motion. So let's call frictional force Fr. So now we can see for this one the reaction force is R. For this one the reaction force is Fr. It tends to prevent the motion. So now frictional force is actually directly proportional to normal reaction. So we can write it like frictional force Fr is directly proportional. So that's directly proportional to the normal reaction, which is R. So frictional force is directly proportional to the normal reaction. So to remove this proportionality sign, we introduce a constant which we call coefficient of friction. So coefficient of friction is represented by this symbol. Yes, we call it mu, mu. So coefficient of friction mu times the normal reaction. So you can say that mu is equals to the frictional force over your normal reaction. So this is the relationship between frictional force, normal reaction, and the coefficient of friction. Take note that coefficient of friction is dimensionless. Why? Because frictional force is in Newton, normal reaction also in Newton. So Newton divided by Newton, they'll cancel out. So it does not have any units. One thing I also forgot to mention is that your R can also be represented as N. Here in some textbooks you see R as N. So, and your R is equals to your W. Yes, that's your normal reaction equals to the weight if there are no external forces acting here, and it only occurs when the body is on a horizontal surface. That's when your R equals to your W. So if you are given your W, you can actually find your R. Okay, so now let's check a quick question. So the question says a box of mass 5 kg is placed on a horizontal surface. If the frictional force is 10 Newton, calculate the coefficient of friction. Okay, so let's calculate. The mass given is 5 kg. So, and we know our weight equals to what? Mass mg. Yes. So our weight is going to be 5, and your g is going to be 10, which is a constant. So 5 times 10 is what? 50 newtons. So your W equals to 50 newtons, which is equal to your R. Alright, now your normal reaction, which is also your normal reaction is 50 Newton. So now your frictional force is given as 10 Newton. So let's call it Fr equals to 10 Newton. So we have to find the coefficient of friction. Now coefficient of friction, if you still remember, coefficient of friction equals to the frictional force divided by the normal reaction. So that's going to be 50. Sorry, that's going to be 10 over 50. 10 over 50. Yes, Fr is 10, while your normal reaction, which your R is what? 50. So 10 divided by 50, which is the same thing as 1 over 5. So 1 over 5 is the same thing as 0.2. Remember, there are no units. So this is the answer. This is your coefficient of friction, 0.2. Alright, now let's talk about the two main types of solid friction, which is static and dynamic friction. So now we have a person trying to push this box on this horizontal surface. Okay, so as it's pushing, is applying a force like this. Now if you notice, when you are trying to push heavy objects, before the object starts to move, it will actually take time. Yes, it will not want to move at first, so you now have to increase the force or the intensity of your push before the body now starts to move. So before that body starts to move, there is actually a force acting on it, and that force is called static friction. So we can call it Fs, static friction. So static friction is the force, yes, is the force that acts on body at rest, so it does not want the body to move. So that's static friction. Why dynamic friction? So when the body eventually starts moving, dynamic friction is the force that acts on the body while it is moving. So as the body starts to move and continues to move, the friction that now starts taking place is what? Dynamic friction. So dynamic friction, we can call it Fd. So this one is acting before the body starts to move. It is when you overcome static friction, that's when you now start to work against dynamic friction. So static friction is the first friction you have to overcome, while dynamic friction is the next friction you start to battle with. So remember I said that your frictional force is directly proportional to your normal reaction. So that's why you have F equals to mu R, where mu is representing your coefficient of friction. So now for static friction, we can replace it as Fs equals to coefficient of static friction Us times R. While for dynamic, you can say Fd is going to be equals to U D times what? R. So dynamic friction can also be referred to as kinetic friction, because it has to do with motion. So this one is static, while this one is what? Dynamic. Yes. And another thing you should know is that the coefficient of static friction is actually greater than the coefficient of dynamic friction. That's why it is harder for you to start pushing a body, but it is easier for you to continue pushing the body when the body starts moving. You understand? So these are the two main types of solid friction: static and dynamic. Okay, so the next thing to talk about is finding the acceleration. Now you want to find the marks to find the acceleration at which this box moves. So now we are told that the force applied, yes, let's call it Fa. There's an opposite force, which is the frictional force. Let's call it Ff, frictional force applied. So we know they are going to be opposite to each other. So the net force, which is the total force, yes, we can now calculate it as F net. So it's going to be equals to the force applied, which is Fa. Now look at the direction. This one is acting like this. You can see that this one is opposing it. So because it's opposing it, it's going to be negative minus F. And don't forget your F, force equals to mass times acceleration for this one. So this one, F is going to be equals to ma. We have m. So we have F net to be equals to Fa minus Ff. So we know our F, force, equals to mass times acceleration. So it's now going to be equals to Fa, then minus, remember frictional force formula. Frictional force formula is what? The coefficient of friction times the normal reaction. So then your acceleration can now be equals to Fa minus nu r all divided by m. So this is how you can calculate acceleration. Alright, so here is a question. So we have a frictional force. So we are trying to drag this box with a force of 40 Newton. So the frictional force is 12. The mass of the wood is 5. Let's find the acceleration. So remember the formula, F, that's F net equals to the force applied minus the frictional force. So F is going to be ma, yes, and is going to be equals to P is what? 40 minus, this one is going to be 12. Now don't forget your mass is going to be equals to 5. So that's going to be what? 5A is going to be equals to 40 minus 12. That's 28. So A is going to be equals to 28 over 5. Your answer is going to be 5.6. A moving car of mass 800 kg experiences a frictional force of 200 Newton. If it accelerates at 2 meters per second squared, calculate the magnitude of the frictional force applied to the car. So we are asked to, calculate the magnitude of the force applied to the car, not frictional force, the force applied. So we know that our net force, which is ma, is going to be equals to our total force, that's the force applied, minus the frictional force. So we know our m is 800 and our acceleration is 2. So that's going to be 800 times 2, and that's 1600. Is going to be equals to our force applied, which we are asked to calculate, minus our frictional force, which is 200 Newton. So we have 200. So bringing 200 to this side, it becomes positive. So our Fa can be equals to 1600 plus 200. So what are you going to get? 1800 Newton. So this is the force you need to apply to the car for it to accelerate at 2 meters per second squared. Here is another question. A force of 10 Newton drags a mass of 10 kilogram on a horizontal table with the acceleration of 0.2 So if G equals to 10 meters per second, the coefficient of friction between the moving mass and table is, so still using that same formula, we know that the net force which is mass times acceleration, is going to be equals to the applied force Fa minus your frictional force. So your mass here is 10, your acceleration here is 0.2. So this is going to be 10 times 0.2, which is 2, is going to be equals to your applied force. We know that this is 10 Newton. 10, then minus. Now remember, your coefficient, your frictional force is coefficient of friction times the normal reaction, and your normal reaction, which is R, is going to be mg. So if R equals to mg, your mass here, it is 10 times your acceleration due to gravity, which is 10. So your R is 100. So you can do this times 100. So then bring this one to this side, bring these two to this side. So you have 100 mu equals to 10 minus 2. So 10 minus 2 is 8. We have that 100 mu is going to be equals to 8. Then divide both sides by 100. You get that your mu is going to be equals to 0.08. That is the answer. Okay, so now this is friction on an inclined plane. So you can see this box is not on an horizontal surface. It is actually inclined at a particular angle. So normally the weight is still going to act downwards. So this is the weight acting downwards. Yes, but now the frictional, the normal reaction is still going to act perpendicular to the surface. So this is the surface. So perpendicular to the surface is still going to be like this. Because if I turn my book like this, you'll be like, oh, this normal reaction is still acting perpendicular to this surface. So now in this case of inclined plane, your normal reaction is not going to be equal to your frictional force. So we have R to be here. Yes, and this your W is going to be acting at a particular angle. It's going to be acting at a particular angle. So this angle is going to be equal to this angle. Now when you resolve this your W into horizontal and vertical components, yes, so your weight is going to be in this side, and it's also going to be in this side. So we have this side to be W cos theta, and we have this side to be what? W sine theta. Yes. So now this force is going to be dragging this box down. Then there will be a what? Force that's going to be opposing the motion, which is your frictional force. So since this force is dragging it down here, your frictional force is going to act upward. So frictional force is going to act like this. It's going to act upward, while this one is going to act downward. So you can see in this case, you can say that your R is not equals to W. Yeah, it's not equal. Look at where your R is going to. It's going up like this. Your W is going down. But you can now say that your R is going to be equals to this one. Yeah, look at them. They are directly opposite each other. They are just acting in opposite directions. So your R is going to be equals to W cos theta. W cos theta. W is equals to mg. So you can say that your R is going to be equals to mg cosine theta. Do you understand? While your frictional force, look at it, is directly opposite this one. So we can say that your frictional force, FF, and this one is static friction because it's preventing the body from sliding. So your static friction in this case is going to be equals to what? W sine theta, which is the same thing as what? Mg sine theta. So take note of these formulas. So if you were to calculate the net force, here's the net force acting here. So your net force, which is F, and your F, F is going to be equal to MA. So your net force MA is going to be equals to, now this one is your we can call it your main force here. So it's going to be W sine theta minus your frictional force. Remember your frictional force formula: coefficient of friction times normal reaction. So coefficient of friction times your normal reaction. Alright, now we proved that our normal reaction equals to mg cos theta. Yes, so we can now replace this normal reaction with what? Mg cos theta, and this W sin theta we can replace with mg sin theta. So we can say that our MA is going to be mg sin theta minus nu, that's mu, times mg cosine theta. Sorry, I'm running out of space. So now we can look, if we look all through, we can see that m is common on both sides, so we can cancel out m. So we'll be left with a to be equals to g sine theta minus nu times g cosine theta. So yeah, this is the formula for calculating acceleration in an inclined plane. So we can also say that a equals to, factoring out g, we can bring g out, we can say sine theta minus nu cosine theta. So this is how to calculate your acceleration. So we just took r and replaced r here. We just did the normal logic, this one minus this one, because they are going in opposite direction. That's what we just did, and that's how we proved our acceleration. So with this, you can actually calculate your acceleration. Yeah, so one more thing to mention is that this is actually when the body is sliding down, because you can see that this force is acting downwards. Yes, that means the body will eventually slide down. So that's why we subtracted there. But if it's that the body was acting down upwards, this W sin theta is going to be pointing up, and if it's pointing up, this and the frictional force are going to be pointing in the same direction. So what do you think we'll do here? We're actually going to add it. Yes, so if the body is sliding downwards, this is the formula. Then if it's sliding upwards, the formula is going to be what? Positive. Do you understand? Yeah. So here are the formulas for calculating acceleration when the body is sliding. So when it's sliding downwards, you use this. When it's sliding upwards, you use this. So it's just a change of sign. It's just a change of sign. And another thing you should know is that in an inclined plane, you can calculate your coefficient of friction using tan theta. Yes, using tan theta. That's another easy way to calculate your coefficient of friction. So let's check a question. A block of mass 20 kg slides down. So take note of this keyword, slides down an inclined plane of frictional force 30 Newton. Calculate the force pushing the block down the plane if the plane is inclined at 30 degrees to the horizontal. So let's represent this in a diagram. So a block of mass 20 kg. So let's draw the inclined plane. Okay, and the inclined plane is inclined at 30 degrees. So let's just do the angle as 30 degrees. So the block, this is the block of mass 20 kg. So the mass here is what? 20 kg. Yes, the mass here is 20 kg. Now don't forget to draw your horizontal and vertical components of the weight. So this side, don't forget, is mg cos theta. So your mass times your acceleration, your mass. So let's just do it like mg cos theta. This side to be what? Mg sine theta. Alright. So now then we said the frictional force is 30 Newton. So frictional force is 30 Newton. This is your normal reaction, your R. Okay. So now let's solve. Alright. So the first thing to calculate is your weight. So your weight is mg. That's 20 times 10, which is 200. Then you calculate, then also calculate this force acting downwards here, mg sine theta. That's 200 times sine 30. Sine 30 is 0.5 times this, get 100. So now your net force is going to be this minus this. So it's going to be mg sine theta minus frictional force, and the frictional force is 30, and we just calculated mg sine theta as 100. So that's going to be 100 minus 30. So the force is 70 newtons. So I asked us to calculate the force that will move, yes, the force that will move the block down the plane. So you say it is 70 newtons. So that's the answer to this question.